Hello everyone, my name is Joshua Foreman and I'm here to present Physics 2212, Lab 2 about lines of charge. So an intro to this is that the previous lab had many assumptions to simplify the calculation required and to accommodate for our lack of knowledge on electric forces and how to properly calculate them in a more physically accurate way that wasn't just here's 2 point charges. This time we had a better approximation by, instead of assuming that 2 pieces of tape are 2 point charges, we assume that they are lines of charge, and we, in a sense, integrate, or in a discrete way, we add over small sections of the tape, and then combine those results together to get a more detailed calculation. Some assumptions, idealizations, or simplifications that we made. We're just ignoring air resistance. We're assuming that each tape has the same amount of charge, which is evenly distributed along the tape. And we're assuming that the forces between the tapes can be approximated well by, like I said earlier, by chopping up a piece of tape into little bits and going bit by bit and treating those bits like point charges. So here's the changing code that counts for that. The diagram above shows the electric force from 2 tapes treated as a set of 10 point charges. Looking at the results, they're actually the exact same for some reason for my lab. I'm not sure what the deal was there. Maybe if we were to split up the tape into even more pieces, maybe we could get some sort of discrepancy. But the models are supposed to be different, because if we assume that a point charge is the only thing, if we're only assuming point charges on point charges for the tape, I'm sorry, let me say that one more time. If we're assuming that each piece of tape is just 1 point charge, that all the charge is collected into the center of the tape, that means the distance between the 2 things we're measuring is smaller, which means given some amount of charge, all collapse onto 1 point, ideally the forces would be larger because same charge but smaller distance, and the formula says that it is inversely proportional to distance squared. The force, that is. And so we should have smaller force with the line charges, but for some reason it wasn't like that. But yeah,